We'll show you what that looks like. In this method, we do not set a polynomial equal to 0. Instead, we set a squared expression equal to a non-negative real number. For example, let's look at this first two. So we want to solve for x, which means we want to get x by itself. It says we're going to solve the following quadratic equations by using the square root method. Write the radicals in simplest form. So in all of these, we're going to get the x by itself. In order to do that, we have to find, we're going to get rid of 3 times x by dividing both sides by 3. So that says x squared is equal to 17. 51 divided by 3 is 17. All right, so now we want to find out, that's what x squared equals. So to find out what x equals, we find the square root of both sides. And so when we find the square root, when we're using the square root method, we're going to find, I put my equal sign too close because really what I want to know is what is the positive and the negative square root of 17. Well, the square root of x squared is x. 17 has no factors that are perfect squares, so the answer is simply positive and negative square root 17. Now in Hawks, they don't have a symbol that looks like this. So in Hawks, you have to type both answers. So it'll give you 2 boxes. In the first box, you're going to simply type square root of 17. And in the second box, you're going to type the opposite square root 17. So those are our 2 answers. All right, letter B. So this is held together by this plus symbol. So we can't subtract 4 because this is all held together inside the parentheses, and then it wants us to square this whole thing. Well, how do you get rid of squaring something? Well, you simply find the square root of it. Whatever you do on one side of the equal sign, you have to do on the other. Now in this section, every time you write that radical on the opposite side of the equal sign, we're going to get in the habit of writing plus and minus. Of course, I don't have enough room here, so I'm gonna rewrite this. So what I did was, the opposite of squaring anything is to find the square root of it. I'm going to do it on both sides of the equal sign. I'm automatically going to put my plus and minus. So that radical and that squared cancel each other. So now we have x plus 4 is equal to the positive and negative square root of 21. So now we still don't have x by itself because we have to subtract 4. Subtract 4. So what are our 2 answers? Our 2 answers are the positive square root of 21 minus 4 and the opposite, or the negative square root of 21 minus 4. Now, if 21 had any factors that were perfect squares, we could pull out a whole number in front of the radical sign. But the only 2 factors of 21 are 3 and 7, and neither of those are perfect squares. So those are 2 answers. All right, so let's move on to some more examples. All right, so you'll see several of these on Hawks. So if it's written like all 3 of these, the only way to get rid of that square is we're going to find the square root of them. Okay, so let's look at letter C first. If I can make this less fuzzy. There we go. I don't know why that works, but it seems to work. All right, so the first thing we're going to do, I'm going to rewrite it so I have a little bit more room. Not changing anything. So the first thing I'm going to do is find the square root of both sides of the equal sign. As soon as I do that, I'm going to put my plus and minus. Don't forget that part. Now these 2 will cancel each other out. And guys, always read your directions, because if you'll read, okay, now I'm doing it the square root method, it'll help you remember that this is what they want, okay? All right, so anyway, the square root of x minus 2 squared is x minus 2. Now this time, we can simplify 50, because 50 is 25 times 2, and 25 is a perfect square, right? So I haven't gotten rid of that 2 yet, but Square root of 25 is 5, and what's left under the radical is 2. So plus and minus 5 square roots of 2. So now I want x by itself, so I'm going to add 2 to both sides. So my first answer is positive 5 square roots of 2 plus 2. My second answer is negative 5 square roots of 2 plus 2. Those are my two answers. And you have to type those into Hawk's two separate answers exactly like it's written there. All right, letter D. So we want to get rid of that squared. So we're going to take the square root of both sides. So we're going to take the square root of this side, we're going to take the square root of this side, and we're going to automatically write plus and minus. We're going to get rid of these because they cancel each other out. So what are we left with under the radical? We're left with 2x plus 4 equals the positive and negative square root of 72. So 72, I'm thinking of the biggest perfect square I could think of that's a factor of 72. Well, that number is 36. 36 times 2. Or I could find all the prime factorization. I could circle all of my pairs, how we did those a few times. Or if you have one of my calculators, type that in your calculator and it'll tell you the answer is 6 square roots of 2. But anyway, if you think of the biggest factor that's a perfect square, that'll help you. So now I know that this is 6 square roots of 2. Plus and minus, 6 square roots of 2. All right, so now what do I do? Well, now I'm going to, think of this as just a linear equation. This is a crazy number, but pretend it's just a 20. What would we do? We would subtract 4, and then we would divide by 2. We're going to do the same thing. We're going to subtract 4. So I'm going to rewrite it so I don't get confused. So 2x is equal to the positive and negative 6 square roots of 2 minus 4. And now what do? I divide everything by 2. Well, I shouldn't have written it like that, but I just want you to see that this is a whole term. I don't worry about what's under the radical. I can't ever divide the denominator by what's under a radical. I can't do that. However, the number in front of the radical, if it's divisible by 2 and the other term is also divisible by 2, then I can divide everything by 2. If they're not both divisible by 2, I'm going to write the whole numerator over the denominator the way it was originally written. We'll do one of those in a few minutes. Anyway, so since I can divide 6 by 2, this becomes a 3, and 4 divided by 2 is 2. So how do we write our answers? So our first answer is x is equal to positive 3 square roots of 2 minus 2, because 4 divided by 2 is 2. My second answer is the negative, or the opposite, negative 3 square roots of 2 minus 2. Those are my two answers. Let's just take some practice, guys.